Hey guys, you made it through one chapter, so let's go ahead and start the next. So in this chapter, in chapter 12, we'll be talking about alcohols, thiols, ethers, aldehydes, and ketones. So a good chunk of our functional groups, we're going to be looking into their properties, how to name them, and some reactions with them. So this particular lecture is the first part of chapter 12. It'll be 2 days worth of lecture material. That is incorrect. I'm going to fix this right now. It is actually chapters 12.1 through 3 for this particular PowerPoint, and then your next note set will just be section 4 of chapter 12. And then I've listed out some practice problems for you guys here. So the first thing we're going to talk about are what alcohols are. So alcohols contain a hydroxyl group. So this should be a little bit of a review because we talked about our functional groups, I think a week and a half ago or so. So alcohols contain a functional or a hydroxyl group. So they look like ROH. R meaning the rest of the molecule. You have an OH at the end. Characteristics and uses of alcohols. So the first one is things such as alcoholic beverages. And this is like ethanol. This is what ethanol is used for. So for example, like Everclear, for those of you who are old enough to drink, is pretty much pure ethanol, almost pure ethanol. And ethanol is metabolized in your body, and it causes effects after it's metabolized to, you guys know, when you get drunk, it's off of ethanol. Okay, and then we also have the uses of alcohols are disinfectants. So ethanol is also a disinfectant, just so you know, but rubbing alcohol, which is isopropanol, which looks like this, is a disinfectant. So the hand sanitizer that we've been using almost constantly through COVID, it will either have a majority of ethanol or a majority of isopropanol in it, and that kills the bacteria, and that's why we use it in hand sanitizer. And the last one is a little bit different, antifreeze. So antifreeze is made out of ethylene glycol, which actually has, it's called a diol. You don't need to worry about that, but it has 2 alcohols on it, or 2 hydroxyl groups. It looks like this. Now this is the stuff that you put in your car to make sure that it doesn't, like your car doesn't freeze, and in your like coolant solutions and stuff like that, is a alcohol. So let's look at naming some alcohols. In order to name alcohols, we use the same name as an alkane, or name the alkane with the longest carbon chain containing the OH. So make sure that the alcohol is in that carbon chain. And at the very end, so you're going to name it the same. At the very end, drop the E instead of the hexane or something like that. Instead of the E at the end, you're going to place it with OL, all. Okay. Number the carbon chain just like you would. Give the name and location of each substituent alphabetically. So you name everything just like you did before. Make sure that the carbon chain has the alcohol on it, and that you put the numbering on the side closest to the alcohol. Even if it makes the substituent numbers kind of bigger overall, you still put the numbering closer to the alcohol, and then put OL at the end. So let's do a couple. So this one here, we have 1, 2, 3, 4. That puts my numbering with the lowest number on the alcohol as possible. So the name for this would be, the normal name for this without the alcohol. So maybe we'll put a little box around the alcohol. If you were to take off the hydroxyl group, the normal name would be butane, but I'm going to get rid of the E there. And we're going to make it butanol. And then we're going to say where that all is, where that alcohol is. So it's at carbon number 2. So this molecule is called butanol. Okay, so let's do the same thing with this guy here. We're going to start out, I'm going to circle, put a box around each of these alcohols. Okay, so we need to name the alkene with the longest carbon chain that contains the alcohol. So we have a carbon chain here. I'm going to go ahead and number it to get the alcohol on the lowest number that it can. 1, 2, 3, 4, 5. So we have pentane, but we're going to drop that E, and then we'll have pentanol. Let's number where that all is before we forget. Drop the E, replace the OL. Number the carbon chain starting with nearest OH, which we did. Let's put the number for the all, and then we put any substituents at the beginning. So we have, let's do a new color. How about blue? Let's do blue. At the 4 position, we have 4-methyl. So the full name for this guy is going to be 4-methyl-2-pentanol. Okay, let's do another one. So step 1 is to name the alkane chain. So we have 1, 2, 3, 4, 5 again. So we have pentane. Drop the E, add OL. Okay, number the carbon chain starting with the nearest OH, what we've got. And then let's label where that all is. So it's at carbon number 2. And then we need to add our substituents in. So at carbon number 3, we have a bromine, 3-bromo. So the name is then 3-bromo-2-pentanol. And the last one is a cycloalcohol. Cycloalcohol. And so for this one, we're going to number, the alcohol is going to be our number 1. So when we number this, we always put the number 1 at the alcohol, and then we'll number around to make the lowest substituents that we can. In this case, we don't have any other substituents. So the name of this molecule, if we didn't have the alcohol on it, would be cyclohexane. But since we do have the alcohol on it, we're going to drop that E, and the name is then cyclohexanol. Since there is only one substituent, we do not need to say where it is. But normally you would need to say that it's at the 1 position if there's another substituent. Okay. And just as a little continuation, this is more of a review than anything else, but we also have phenols, which are a functional group that is kind of a mix between an aromatic group and a hydroxyl or an alcohol. So a phenol is a hydroxyl group on a benzene ring or an aromatic ring. So it looks like this guy here. That is just called phenol itself. Characteristics and uses, the one that I chose to show you guys are essential oils. So nutmeg, thyme, cloves, and vanilla are all phenols. You can see them here. We have phenol as the base of these molecules, and then they have other substituents on them as well. But these are all things that we use as essential oils and put in your oil diffuser. So if you've ever had these, or thyme, I actually have a cleaning solution that has thyme in it, or thymol is, I think, technically the correct word. I'm not even sure I'm pronouncing that correctly, but you know, that's how life goes. but these all have phenols in them. So that's where we see phenols a lot in everyday life. Additionally, there's a lot of news about, maybe not so much as much anymore, but you guys, I'm sure, have seen this before. In the use of plastics, phenols are actually a big deal. So bisphenol A is the full name for something called BPA. So if you haven't heard of this before, you probably have, but you hear of a lot of plastics that are BPA-free plastics. Well, this is a molecule that's used in the making of the plastic that they use for a lot of different things, and saying what the issue is that as this plastic wears down over time, it releases this molecule here that's biphenol. And if you're ingesting this molecule, it's an estrogen mimic. So your body thinks that it's estrogen, but it's obviously not. So markets have actually been done a lot of research and put different molecules in instead of this BPA in order to make BPA-free plastics. However, the other molecules that they're using are still estrogen mimics, so it's not really much better. So use at your own risk. But that's what they're talking about when they say BPA-free plastics, is that it does not have this biphenol molecule in it. And lastly, real quick, naming phenols review. So we had this back in chapter 11.8, but phenol is going to be our base name instead of like the number of carbons or anything like that. Phenol will be the base name. We number the aromatic ring starting at the hydroxyl group and then add substituents as prefixes. So for example, this one's just phenol. Doesn't have anything else in it. This guy here, we start numbering at the hydroxyl group, and we go around 2, 3, 4, 5, 6. So this is going to be for bromophenol. So phenol is our base name, and we show our substituent for bromo. Okay, and now we do this one. We're going to number the opposite direction in order to put our first substituent at the lowest number. So this puts our substituent at number 2. So we have 2 bromo and 5 chloro. B comes before Cl, or yes, B comes before C. And so the overall name, we're going to name our substituents 2 bromo, 5 chloro, phenol. And our last one, we have a number 1 at the oxygen. Always start with number 1 at the oxygen. And I'm just going to label number 2 here because that's my only substituent. We have 2-ethyl phenol. Okay, that's where we're going to stop. This was reviewing or talking about alcohols, and we're starting to talk about alcohols, how to name them, and phenols as well. I'll see you guys in the next one.